Hi guys, we'll be going over 3.4 differentiating inverse trig functions. And I want to go over some key concepts of this unit right here. And these are some formulas that I have to memorize, which is the inverse trig derivatives. And they're very, very important to memorize because these will be helping us for the formulas for doing these type of problems. But yeah, the derivative of sine is equal to 1 over square root of 1 minus x squared. And cosine, you just add a negative in front of it. So like what I like to do is just memorize all three of these and just memorize the trig that function that matches it and just put a negative. So it'll make it easier, you know? But secant is a 1 over x absolute value square root of x squared minus 1. And for CSC, I still cannot pronounce it. I'm going to find a way to pronounce it. Sorry, Miss Jensen. You just put a negative in front of it. See, isn't that perfect? And it just made it so much easier. But for derivative of tan, it'll be 1 over square root, not square root, 1 over x squared plus 1. And for cotangent, you just put a negative in front of it. So this is like very important to memorize. That's why I wanted to include it in the video. But yeah, let's get into our problems. Okay, so as we get into we're gonna get into question 1. So question 1 is basically just, you're just going to find the inverse of this trig function. So d over dx, so with respect to x, whatever, arc tangent in parentheses 2x. So automatically, I like to break down the problem. So arc tangent is basically just this reworded. So don't let the arc fool you at all. But the inverse trig and derivatives we saw earlier. Yeah. So what we're gonna do is just get the formula of it. That's it. And then, but for this part, the x, you plug in 2x for x. So yeah, hold on. I did this whole thing wrong. Basically, we're supposed to do chain rule because this whole thing is on the outside of the parentheses, but that is no problem. So your formula will be 1 over x squared plus 1 times derivative of, d over dx, and 2x, the derivative of 2x would just be 2. So, and for this x right here, you're plugging in what's inside the parentheses, because remember chain rule, it's like a layer, like the onion layers. You do one layer at a time. So when you're doing the derivative of the tan, you don't do the derivative of this. So you keep this. So it would just equal 2 over, I don't really like putting d over dx. A lot of people do it, but you're just taking the derivative of it, of the function or whatever. It doesn't really make sense to me, but okay. But 2x in parentheses square plus 1. And just simplify it. So it'd just be 2x over 4x squared plus 1. And you can simplify that. Well, I'm not going to simplify it because I don't know. But yeah, that is your correct answer. And for number 2, it's the same thing, and we're just gonna be getting the inverse trig derivatives formulas. So it'll be 1 over, negative 1 over, since this is tan and this is cotangent. So cotangent will be the negative 1. I gotta remember that. And it would just be, what is it in? Oh, this is 4x to the power of 4. So 4x to the power of 4 plus 1. And just get the derivative of that, which is what's inside. So it'll just be 16x to the power of 3. So yeah, you're just deriving it and simplify it down. So negative 16x3 to the power of 3, sorry, over, oh, I forgot to put my 2 out here. Don't do that. So that would be 8x to the power of 4 times 2, 8. Oh, that's not 8. That is 16. Yay. Plus 1. And so, yeah, because remember, square this one. These are only 2 you multiply. Exponent rules, I know. Algebra will get you. So, yeah, that is your correct answer. I'll see you later. Bye.